All right, guys, this is number 19 from chapter 22. So we have a light ray from problem 18, and all they told us in problem 18 is that the index of refraction for this glass is 1.5. So n equals 1.5 for the glass. It doesn't say so, but you can assume that this glass is sitting in air, and that's an unstated given. You're expected to know that air is basically a vacuum, and the index of refraction for a vacuum is 1.0. So we have air, glass, and then down here is air. So this is also n equals 1.0. All right, so what we're trying to find is this path difference. So the ray comes in, this incident ray strikes the boundary between air and glass. Some of it gets refracted, and then it hits this boundary here and then gets refracted again. One thing you'll notice on this diagram, what's not being shown that you should show if they ever ask you on on the AP test to diagram the path that the ray follows, what's the thing that you would want to include? The reflected ray. You'd want to go boom, show the reflected ray at each boundary like this. In fact, I would even take that one up to there, draw in a normal line, you get more reflection, and then more refraction like that. Okay, but we're just focusing here on the refracted rays. We want to find the path difference between this refracted ray and the initial path of the original incident ray. So we're looking for this little distance d. The thickness of the glass is 2 centimeters. So I'm going to blow up this. I'm going to get rid of this text. We don't need this anymore. We know what we're doing. And I'm going to make this diagram big. Okay, so the first thing you want to solve for is what? We got to solve for the angle. So I'm going to extend this normal line through like this. The first thing I'm going to find is this angle in here. When you're doing optics problems, you want to measure the angles are always measured off the normal line. So we're going to find this angle in here. So we're going to call this N1. This is going to be N2. This is going to be theta 1. And then in here, this is going to be theta 2. So we can use Snell's law. We're going to go N1 sine theta 1 equals N2 sine theta 2. You plug everything in. N1 goes there. Theta 1 goes there. N2 is there. When you solve this out, theta 2 comes out as 19.47 degrees. This angle in here is 19.47, right in there. Okay, now, next thing. The full angle in here, so what must this whole angle be? That's 30 degrees, right? So if this is 30 degrees up here, then in here, this is going to be 30, which means what must this angle in here be?
30 minus 19.
That's going to be 30 minus the 19.47, and that is 10.53. So this little angle in here is 10.53 degrees. Okay, so what I did, my solution for this is I made some triangles. So I dropped this down like this, and then like this. So we can find this hypotenuse here. This is getting messy. Hold on. I'm going to make this even bigger. I need a ginormous diagram. When I say ginormous, I mean like, ready? So we can totally see this. Okay, so here's what we got. Okay, so bring this down like this. So what I did, so we have this angle in here. This is 19.47 degrees. And so this makes a right angle right here. So what I did is I solved for this hypotenuse right here. I'm going to find that distance right there. So how am I going to find that distance right there? Using trig. So we know this length. What's this length right here? That's 2 centimeters. So that side is 2 centimeters. We got this angle here. So how can we find this hypotenuse? That hypotenuse right there we're going to find that with cosine. Cosine 19.47 degrees. Cosine's adjacent over hypotenuse. Adjacent to the angle is 2 centimeters. Let's just call this h for the hypotenuse. When you solve that out, you get the hypotenuse equal to 2.1213. And you don't want to round here. 2.1213 centimeters. So now that we have that, let's make another triangle. Now this triangle is going to go like this. And that's exactly what we're looking for, isn't it? That little d, that's the distance we're looking for. So that makes a right angle right there. We have this angle in here. Remember, what's that angle? That's 10.53. So now that we have that, and we now know the hypotenuse, this hypotenuse down the middle right there, that it connects the two triangles. That's, so now we're going to use sine, right? To find this little d right here, we're going to go, so we're using this triangle right here to find that d. So sine of 10.53 is equal to opposite over hypotenuse, which is 2.1213 centimeters. So when you solve that, you get 0.39 centimeters, which is the answer. So not crazy hard, kind of tedious. The key to this problem was recognizing that you had to make triangles. When I did this, I'm like, okay, so we're going to need 2 triangles. So I started with this triangle right here, right? Found the hypotenuse. Once I had that done, well, then I made another triangle that shared that same hypotenuse.